everyone. Welcome. Good to see you here this evening. Glad you could make it. Let's tend to the usual pre-lecture business really quickly here, and then we'll get the show on the road. There will be sign-up sheets for the professors who told you. There will be extra credit for attending outside of the auditorium at the end. There's also going to be a QR code, as promised. And just a reminder that after the lecture, our speaker has graciously agreed to meet with Alpha Chi downstairs for a Q&A, an auxiliary Q&A session, I believe called Talkback. And so with that out of the way, our dean, Dr. Luke Fetters, has agreed to open us in prayer, and then we'll introduce the speaker.
Let's pray. Father in heaven, thank you for revealing something of yourself to us in your word, in the structure of your creation, and in your image that we recognize in each other. There's so much more to you than we can know or even pretend to know, and yet you invite us to continue to explore. Thank you for Dr. Howell, for his mind, for his disciplined study, and for what he has prepared to share with us this evening about his understanding of you and how you have designed the world in which we find ourselves. Guide our minds to help us attend. Guide our hearts to help us discern. Bless our thoughts as we turn them toward you. Amen.
Within Forrester Lectures, there are actually several varieties, and this is a rather special one. This is classified as a Walter and Georgiana Ball lecture, meaning it contains somewhat of a conservative perspective. Loosely, and Professor Howell will correct me if I'm wrong, a progressive or liberal perspective on tonight's topic might say that only the language and methods of science can ultimately lead to truth. Professor Howell intends to argue against such scientism and present a more conservative point of view. So let me introduce the speaker. Professor Russ Howell received his Bachelor of Science from Wheaton College, did a Master of Science at the University of Edinburgh in Scotland, and got his PhD from the Ohio State University. He is the Kathleen Smith Professor of Mathematics at Westmont College, and along the way throughout his career, he has held visiting positions at UC Berkeley, Calvin University, University of Maryland, Oxford University, and the United States Air Force Academy. He has twice been honored by the student body at Westmont as Teacher of the Year and served in the U.S. Army in South Korea and was a leader of Westmont's Europe and Mexico semesters, so studying abroad with students. In terms of scholarship, he's a co-editor and contributing author to a text called Complex Analysis for Mathematics and Engineering in 2012, co-editor and contributor to Mathematics Through the Eyes of Faith in 2011, and a title, Mathematics in a Postmodern Age, a Christian Perspective, 2001. He's well-versed in all the arts. He's a piano player. He enjoys tennis and ocean kayaking and hiking. In this case, there's a little bit more. We're very privileged to have Professor Howell with us, and this is mostly facilitated because he's been selected as the inaugural Brabenec Lecturer. And this is awarded by the Association of Christians in the Mathematical Science. So if I may, just a brief background about Professor Brabenec, who this lectureship is named after. He began teaching mathematics at Wheaton College in June of '64, and in 1977 began the organization that is now called the Association of Christians in the Mathematical Sciences. And it is that organization that has brought Professor Howell on what we call his Midwest tour. And it starts here at Huntington University. Tomorrow morning it goes to Taylor University, and then on to IWU before going back to Westmont. And so we should be grateful. We have that organization and, of course, Bob Brabenec to thank, and, of course, Huntington University for providing us this forum and these facilities. With that introduction, I'd like to introduce our speaker, Professor Russell Howell.
Thanks very much, Dr. Drury, and it's a pleasure to be here at Huntington. I'd like to thank the faculty who have hosted me so well, and I had a great dinner with some students. It might start off, if you look at that slide carefully, that I'm reinforcing a stereotype that mathematicians can't spell. You might notice the word mathematics is misspelled there. I wanted to change it when I got here, but it would have taken 20 minutes to set things up, so we'll just live with that stereotype. If you might notice above that, the title of the lecture is a two-parter. Is faith required for mathematics? Is mathematics required for faith? Now, most people, I would suspect, would give a resounding no as an answer to both those questions. So it might not surprise you that because this is a lecture, that I'm going to give an enthusiastic yes. So let's get right to it. Why would I say part one, that faith is required for mathematics? Well, it began, my thinking about this, with an email I got from a mathematical acquaintance. And during dinner, I noticed that one of the students had a very good speaking voice who's a media arts major, and that's Eleanor. And Eleanor, I'm going to ask you to project, because I want sort of an outside voice as someone sending me an email, how it would affect me.
Having never understood how a rational person can possibly subscribe to the Christian dogma, except for having some strong overriding subconscious need, perhaps, I'm curious about it. Although if it all comes down to faith, well, I have never had any idea what that really means, and I don't think I have any in me, except perhaps my ability to reason.
And then there's sort of a coda at the end.
By the way, I'm a happy member of the Skeptic Society out of
Altadena. It's a city sort of east of LA, maybe 30 minutes drive, depends on traffic. Between 30 minutes and 5 hours, depending on traffic. So that thinking is really nothing new, but it's a common view today. Logic and reason belong to the science sphere. Faith belongs to the religious sphere, but it's only the conclusions of science that can give us firm knowledge. Maybe some of you have friends that think that way. Certainly this person did. And it reminded me of an episode that is due to that occurred in 18th century England that caused a theologian, mathematician, named Bishop George Berkeley, Bishop of Cloyne, Ireland, to write an essay, the title of which was The Analyst, or A Discourse to an Infidel Mathematician. So who is that mathematician, and what did the essay say? Here's how he begins. Though I'm a stranger to your person, yet I am not, sir, a stranger to the reputation you have acquired in that branch of learning which hath been your peculiar study, nor to the authority that you, therefore, assume in things foreign to your profession, nor to the abuse that you, and too many more of like character, are known to make of such undue authority, to the misleading of unwary persons in matters of highest concernment, and whereof your mathematical knowledge can by no means qualify you as a competent judge. Now, a lot of people think, because it's called The Analyst, an essay addressed to an infidel mathematician, and because the essay criticizes the calculus that had just been formulated by Isaac Newton, that Isaac Newton was the infidel mathematician. That is certainly not the case. For one reason, Berkeley, in his essay, criticizes those who admire Newton for his mathematics, but deride him for his religion. Newton was a very religious person. He believed in the scriptures, wrote commentaries on Revelation and the book of Daniel, predicted that the world would end in 2060 based on his reading of Daniel. He was not a Trinitarian. He couldn't wrap around his head the idea of three persons in one for the Godhead. We'll talk about that a little more later. So it wasn't Isaac Newton, but who was it? Well, if it was anyone, and I'll talk about if it had been anyone, there's some dispute about whether it was really any one person. If it was one person, it would have to have been Edmund Halley of Halley's Comet, because of an incident that occurred. So Samuel Garth, a London physician, was gravely ill. Berkeley sent Joseph Addison, who was a member of his congregation, to visit Garth and to try and persuade him to confess Jesus Christ as his Lord and Savior before he died. And this is what Garth's reply was to Addison. "Surely, Addison, I have good reason not to believe in those trifles, since my friend, Dr. Halley, who has dealt so much in demonstration, has assured me that the doctrines of Christianity are incomprehensible, and the religion itself is an imposture." Now that fits with his line that I read earlier, "You have swayed those in matters of highest concernment," meaning matters pertaining to faith, and you have dissuaded them. Edmund Halley was an atheist, so he's talking about, look, this guy has assured me that the doctrines of Christianity are I'm not going to believe in that. Now that's the story. I discount that as at least the proximate cause for Berkeley writing the essay. Berkeley's essay was published in 1734. This incident occurred in 1719, 15 years before the publishing of The Analyst. And in any case, Berkeley was in Italy at the time. Now, I suppose word could have come to him by letter or something like that. I think maybe the incident did take place. By the way, the account of of this biography by Joseph Stock is highly disputed, so it's not given a lot of reliability. In any case, I think a more proximate cause has to do with criticisms that Edmund Halley made of a book that Berkeley had published in 1732, just 2 years before The Analyst. And that book, let's see, have I backed up correct? All right, so that book is highlighted. Can you see that middle bit? I had a magnifying thing, but it's called The Author of the Minute Philosopher. That was the title of Berkeley's book, The Minute Philosopher. So what is it and who is the minute philosopher? Actually, the full title is Alciphron, or the Minute Philosopher. It's like maybe 700 pages. It's not a big book. It has 7 dialogues between Alciphron and his associate, and Euphenor and his associate. Alciphron, we don't know a lot about him, but he was a famous Greek skeptic. And so probably Berkeley chose that name to be sort of the foil. And they would argue with each other, Alciphron and Euphenor, about a sweeping movement in the UK known as the free thinking movement. So what are the free thinkers? And this is a book that's a tract against them. Free thinkers viewed religious people as engaging in sloppy thinking with unclear, non-empirical reference. The only way to gain truth was to use logic and reason. No free thinking person would have room in his or her belief system for paradox or mystery or things like that. And they pointed to religious disputes as evidence. They saw religious people as superstitious, illogical, not scientific at all. That was sort of their shtick. Their methodological approach, if any of you here are philosophy majors or studied philosophy, they dovetail nicely with John Locke's theory of language, where clear ideas in the mind of one person can be successfully communicated to clear ideas of another. That's maybe painting with too simplistic a stroke, but that was John Locke's view of language. He was a British empiricist, as was Berkeley. And you might have studied, there's a famous trio of British empiricists, Locke, Berkeley, and Hume, that sort of formed a heyday of British empiricism in the 1700s. So just to give you an idea of the pamphlet wars going on at the time, here's what, you get the idea of what the essay is about just by reading the title. Christianity Not Mysterious. That's the main title, subtitle, or a treatise showing that there is nothing in the gospel contrary to reason nor above it, and that no Christian doctrine can properly be called a mystery. So you get the idea, no mystery, no paradox, nothing like that. Reason, logic, that's our shtick. A little closer to Berkeley's time, a discourse concerning reason with regard to religion and divine revelation, wherein it is shown that reason either is or that it else ought to be a sufficient guide in matters of religion. Now, I don't want to be misunderstood. Berkeley was all for careful thinking. He just objected to the idea that there can't be any room for mystery or paradox in the Christian faith. So that's sort of illustrated in another subtitle of this is his whole document, at the cover page of it. He takes aim at these free thinkers with a slightly different tack. I don't know if you can read that bit, but it says, wherein it is examined whether the object, principles, and inferences of the modern analysis, in other words, Newton's calculus, are any more distinctly conceived or evidently reduced than religious mysteries and points of faith. So that's what Berkeley's going to do. He's going to take on the proponents of Newton's calculus and argue that they are worse in their thinking than they claim theologians are in theirs. And you can get another sense of that by him quoting from Matthew chapter 5. First, cast out the beam in thine own eye, and then you will be able to see clearly to cast out the mote from thy brother's eye. So there it is. That's the full cover page. You kind of know what he's going to be doing. And what was Newton's calculus about? Do you know that the reason why he did calculus because he wanted to study the path of comets? And he is best known for his laws of gravity. Where would a comet go if there were no gravitational pull on it? Well, it would go in the direction of that red line you see, the red tangent line. That would be the velocity line of the comet, if all of a sudden a planet that was pulling on it disappeared. How do you get the equation of that tangent line? Well, it seems impossible, because to get the equation of a line, you need 2 points. And a tangent line, by definition, is just tangent to a graph at 1 point. If you had calculus, you know what Newton did. He said, well, let's get the equation between 2 points. The way I've illustrated this, it's just for illustration. We'll call this number 1 here, the point 1. And we'll go a little distance beyond it, which Newton called, and he really used this label, O. He called O an evanescent increment. So evanescent meaning it just appears for a while and then vanishes. Now, the way you get the slope of a line, you might remember, it's the rise over the run. The rise will depend on what the curve is doing, but the run is always O. And Newton's very clever idea was, let's get O smaller and smaller. Look at what happens to the slope to that line between the 2 points. Do you see that it gets closer and closer to that red tangent line? There we go. But how do you get the line? Well, an exact calculation works something like this. I can't magnify this, unfortunately, but here's the point 1, here's the point 1 plus O. Just hypothetically, let's say the equation is y equals x squared. Don't worry if you don't understand all these calculations. It's a standard thing that calculus students do. And you notice you get from equations 1 to equation 2 to equation 3. To get from 1 to 2, you cancel the O's. And that, to get from equation 2 to equation 3, you just pretend that O is nothing. So Newton declared, the slope of the line that's tangent to this curve right here, the velocity, he called it a fluxion. It's the velocity of an evanescent increment, that was Newton's language, is exactly equal to 2 at that point. Now, Berkeley did not doubt for a moment that Newton's calculations were correct. I mean, that the answer was true. But it's not valid, because if O is 0, equation 1 makes no sense. You can't divide by 0. That was Berkeley saying. It would, and let's hear Newton in his own words. But whereas O is supposed to be infinitely little, this is from Newton's book, that it may represent the moments of quantities, the terms that are multiplied by them in respect to the others will be nothing in respect to the rest. Therefore, I reject them. All right, that's sort of like here, I'm going to reject or expunge. He actually uses the word expunge here. This being done, all the terms of third order will still be affected by O of one or more dimensions, and may therefore be expunged as infinitely less than the others. All right, so Berkeley said, look, I think the conclusion is right, but your thinking is sloppy. It's a bad argument for a good cause. Let me have a student volunteer. Reduce that fraction to lowest terms. Anyone want to call out the answer?
That'd be 1/8.
1/4, right? You all agree? Reduce it to lowest terms. Good, 1/4. Now suppose I would say, right, how did you get that? Well, it's 1/4. I canceled the 6's. And then I expunged them. And then cleaned things up. Okay, say 1/4. So that's not going to work. Is 13 over 32 equal to 1/2? No. So again, Newton said, your conclusions are right, your reasoning is wrong. Let's hear, Berkeley says this. Let's hear Berkeley in his own words. So remember, this is the calculation. O is an evanescent increment. The slope is the velocity of an evanescent increment. We're getting the velocity to be 2 by expunging. Berkeley says this. I now beg leave to make a new supposition, contrary to the first supposition, that there is no increment in x, or that O is nothing. That was going on in that equation. And I get an expression obtained in virtue of my first supposition, and which could not be obtained without it. All of which seems to be a most inconsistent way of reasoning, and here's kind of the punchline, and such as would not be allowed of in divinity. So, like I said, he's saying his criticism is, you are worse in your thinking than we theologians are in ours. And here's an example. Another comment in his essay. And what are these fluxions? That's what Newton called his slope. The velocities of evanescent increments? And what are these same evanescent increments? They are neither quantities nor quantities infinitely small, not yet not nothing. May we not call them the ghosts of departed quantities. I love that line, the ghosts of a departed quantity. Now, those of you that study some philosophy, Berkeley was an empiricist, but he was an empirical idealist. He did not believe in the existence of an external material world. His famous mantra is esse est percipi. To be is to be perceived. The reason we exist is because we're always perceived by a divine being, namely God. There's a famous limerick that goes along with that I'll tell you about in a Q&A if you're interested. But It was mentioned I had a year at Oxford University, so Berkeley spent his last days at Oxford at Harris Manchester College, and there's a little plaque in the house where Berkeley lived, and I showed it far away because there's a punchline, if you look at it close up, that shows classic British humor. Bishop George Berkeley, philosopher, is perceived to have lived and died here. Now, just playing around with it with a Photoshop, Bishop George Berkeley, mathematician. You see, his first publication was really in mathematics, and he was also a trained philosopher, one of these sort of polymaths that was good in everything. That's maybe one reason why the essay was not directed necessarily at Halley, but to the establishment, the free-thinking establishment. He was sort of an outcast. I mean, hardly anyone was an idealist in his days. You know, most people believed in the external world. He was also a Tory. Everyone else around his circle was a Whig. So he was kind of socially outcast, but he was really bright. So you couldn't put him down, so to speak, in any kind of verbal argument. He wrote the essay. 2 days later, he got on a boat and went back to Ireland. So some people think this is his, you take this, you British free thinkers. I'm leaving. But that's kind of irrelevant to the main point of his essay. What do we do with that? So look at what is the assessment of Berkeley? His ingenious criticisms in the Analyst remain to this day unanswered. This is in 1833. This is before Augustin Louis Cauchy got the idea of limits in France that kind of firmed up the foundation of Newton's work. But this is almost 100 years later, after the essay, The Analyst, and still, his criticisms haven't been answered. The fact is that Newton himself had no knowledge of the true nature of his method and of prime and ultimate ratios. And even later, an expert in George Berkeley, Douglas Jessup, who is at Florida, wrote a book called D'Amato and the Analyst, and he says, in the Analyst, Newton's procedure here is utterly mysterious. We don't really know what he was thinking about. It works, but he didn't have any really firm basis for judging those conclusions to be true. So, regardless of whether they knew it or not, the thinkers of calculus in Newton's time relied on faith. It was, look, these results work. They're powerful. We can use them to predict things like the path of comets and so on. It wasn't irrational faith, it was reasoned faith. But it took well over 100 years to firm up the logic of calculus, as I said, by Augustin Cauchy with his theory of limits. But we might ask, well, okay, that was then, this is now. Is faith required for mathematics today? And I would say, oh yes, yes it is. Let's see how. So what was needed, demonstrating what was lacking in Newton's work, was a method for axiomatizing the continuum. The axiomatic method of doing mathematics, this is how mathematics is practiced today, was started in 300 BC, when Euclid wrote his book, The Elements. You might have remembered studying that when you had high school geometry. You begin with certain axioms that are things that are worthy of belief. You accept they're so obvious, you say that they're true. One of Euclid's axiom is, between any 2 points, you can draw a line. Seems good. The Greek word axios, from which axiom comes, means worthy. In fact, in Revelation chapter 4, you see that word. Worthy are you, O Lord our God, to receive glory and honor and power, for you created all things, and because of your will they existed and were created. Axios, worthy are you. So we start off with these axioms, then we build our edifice. We use our axioms to prove propositions and have definitions that go alongside of that. And from that, we create our system. So there was this drive to axiomatize the continuum. How can we firm up, put all of mathematics on an axiomatic basis? So a big step was taken that way by Gottlob Frege in 1903. He was what we term as a logicist, who had the view that all of mathematics can be reducible to logic. And I'm going to publish a book that has just 5 axioms in it, just sort of like Euclid's geometry. And from these axioms, we're going to be able to prove all of arithmetic. Well, the book was called The Grundgesetze der Arithmetik, stands for Foundation of Arithmetic. It was volume 2. Just before he published that book, he got a disturbing letter from Bertrand Russell. And you might have heard of Russell's paradox, but that letter essentially said, I've got bad news for you, Frege. Your 5th axiom is in conflict with your other 4. In other words, your whole system is inconsistent. So you have, with your system, things that say opposite things. And this was very disturbing to Frege to realize that, and he tried to patch things up as a last minute. And he modified his 5th axiom, put it in an appendix. Publication was too far along to stop production, so he had an insert in the appendix. And here's what he says. Hardly anything more unfortunate can befall a scientific writer than to have one of the foundations of his edifice shaken after the work is finished. This was the position I was placed in by letter of Mr. Bertrand Russell, just when the printing of this volume was nearing its completion. So he has this appendix, puts it in there. It was subsequently shown that his appendix, his fix didn't work either. It was also inconsistent. And so what do you do now? We've got an inconsistent system. Well, mathematicians kept working. Bertrand Russell himself, working with Alfred North Whitehead, finally published a volume. It extended over many years because there were different editions. Last one was completed in 1925 to 27, called Principia Mathematica. Your library probably has it. It's a famous work. Although it wasn't famous at the time, in fact, to get Cambridge to publish it, they took their manuscript in a wheelbarrow to Cambridge Press and had to pay him £200 as a bribe to publish it. So it was a good investment by the publisher if they had taken it. In any case, this is one of the parts of it. Now, I don't want to pretend to have you understand the notation. I just want you to look at how amazingly logically complicated it looks. This is just a work of raw logic. And at the end, from this proposition, it will follow, when arithmetic addition has been defined, that 1 + 1 = 2. So this is amazing work of logic. If you have it, just get it and just thumb through the pages, if nothing else. It would be a real treat. All right, so game is on. Okay, now we've got this system that will do all of mathematics, and we're going to be surefire, no uncertainty, no ambiguity. By the time David Hilbert wrote around in 1930, he took that a next step, and he is what's known as a formalist. And he said, we're going to take these axioms, strip them of meaning, and view as mathematics as just a game that works in accordance with rules, to combine axioms in certain ways according to rules of reasoning, which are just fundamental logical principles. And from that, we will be able to derive all of mathematics, to be able to prove everything. Principia Mathematica. Here's what he said in 1930. The fundamental idea of my proof theory is nothing other than to describe the actual activity, or to describe the activity of our understanding, to make a protocol of the rules according to which our thinking actually proceeds. Already at this time, I would like to assert what the final outcome will be. Mathematics is a presuppositionalist science, presuppositionaless science. To found it, I do not need God, nor the assumption of a special faculty of our understanding. That was 1930. Just 1 year later, something happened that undermined his whole idea completely. It was due to the work, this is a picture in 1938, of a logician that many of you may not have heard of, Kurt Gödel. This is his wedding day photo, so that's why I showed it. You probably have heard and recognized the person that he was with, photo taken in 1950. Who is that person to the right? Albert Einstein, yeah. So that was the league that Gödel was in. Here's a photo of him mid-career. Gödel did his undergraduate work at the University of Vienna. And in 1994, I led you mentioned that I led a student group to Europe. So we went through Vienna, and I went to their archives, and I was able to find a picture of Kurt Gödel as he was a freshman. How many of you would like to see that picture, Kurt Gödel as a freshman? It's remarkably similar to what freshmen look like today. Here it is. And here he was his sophomore year. Can you tell any change between sophomore and junior year? Okay, that's enough silly. Here's his senior year. Okay, so he cleaned up his act. All right, enough silliness for that. So here's what he proved in 1931. He proved what's now known as his incompleteness theorem. Remember, PM is the work published by Bertrand Russell and Alfred North Whitehead. And he proved this. If PM, Principia Mathematica, is consistent, if it is, it contains true propositions that can't be proven to be true. And it contains false propositions that can't be proven to be false. Here's his exact, I guess I can't avoid a little technicality. So this says, if there exists a y for which there is no x that can demonstrate y, then there is no x that can demonstrate this proposition. So the first part, if there exists a y that can't be demonstrated, that's equivalent to saying that my logical system is consistent. Because in an inconsistent system, everything can be demonstrated. So if there's something that can't be demonstrated, if the system is consistent, then this statement can't be demonstrated. Now, these free thinkers that I mentioned earlier, that were sweeping the UK in the 1700s, they were a forerunner of what we would call logical positivists. A logical positivist, sort of a dead school in philosophy these days, but it's really active among many scientists in terms of how they practice and believe things, held that in order to be meaningful, a statement had either to be empirically verifiable or, if not empirically verifiable, logically deducible from prior established truths. Other than that, a statement has no meaning. So, Jesus Christ was raised from the dead. Okay, in principle, that can be empirically verified. God raised Jesus Christ from the dead. No. That can't be established logically, and it's certainly not empirically verifiable, so that's a meaningless statement for logical positivists. All right, well, this result was a blow to the logical positivists of Gödel's day. Gödel actually sat in the Vienna Circle when logical positivism was being developed. He sat in the back, didn't say much. But look what he did. He produced a statement that was not only a meaningful statement, that was not only non-empirical, but also provably not logically deducible if the system is consistent. Really quite a blow to not only Gödel's program, but the logical positivists. The second thing he proved is, if Principia Mathematica is consistent, you will not be able to prove that it's consistent. All right, well, what if we get some other system? Well, anyone know what the axiomatic system for almost all of mathematics is today? It's called ZFC. That was formulated around 1922. Depending on its formulation, it amounts to about 10 axioms. Well, Gödel, by the way, ZFC stands for Zermelo, Frankel, the two mathematicians, and C stands for the continuum hypothesis. If ZFC is consistent, it can't be shown to be consistent. And not only that, not only worse, my theorem applies to any axiomatic scheme you can possibly create that will produce an arithmetic that is powerful enough to do addition and multiplication. So give it up. You're not going to be able to prove your system is consistent. So let me back up one here. So is faith required for mathematics? You go to any mathematician, any university today, unless they work in the logic, in the area of logic, I guarantee they will not be able to list the 10 Zermelo-Fraenkel axioms. They will not be able to. And not only that, if you ask that person, well, why do you think these axioms that you can't list are even consistent? How do you know that you're working? About 5 years ago, there's a philosopher of mathematics at UC Berkeley named Christian Anderson, and rumors spread that he found a contradiction in ZFC axioms. Did it upset me? Do I go, well, I'm going to stop teaching mathematics and raise puppies? No, I thought, well, we'll work something out. A mathematician will say, if a person is honest, why do you believe arithmetic is consistent? Well, the answer will be, I've got plenty of evidence. No contradiction has risen in over 100 years. The results of mathematics work in the physical world. They're very powerful. They give me collectively the evidence of something I can't see, namely a proof of the consistency of mathematics. The substance of things that I hope for, a proof of the evidence of something I can't see, the substance of something I hope for. Look at Hebrews 11:1. That's the definition of faith, at least in Hebrews 11:1. So, faith is required for mathematics today. Be interesting to tease out, is it the same kind of faith? I think it is, that Christians would have. This won't take nearly as long. The second half of my talk, second part, it'll only be about 10 minutes, is mathematics required for faith? Required? Well, I'd say yes, but in the words of a well-known politician, it depends on what the meaning of the word required is. If you use the meaning of the word required as can be helpful in enhancing and enriching your faith, I'd say yes. Let me give you a couple of examples. Arthur Holmes, in his well-known book, The Idea of a Christian College, lists 4 categories for approaching faith and learning. I have an essay in Journal of Scientific Affiliation where I talk about those 4 categories there and how they might apply to mathematics. I want to talk about a 5th category that I suggested could be added to this list, called the pranological. And I take that from combining the word practical application of an analogy. I don't think it's ever going to make this into the Oxford English Dictionary, but let's go with it, the pranological approach. So if you study mathematics, you will learn this, that there are different, at least conceptually, levels of infinity. One infinity can actually be a larger number than another level. If you see the proof of that in a mathematics course, you will walk away with a richer understanding, a more amazing understanding of language that talks about God being infinite. But there's even more than that. And I'd like to suggest that there's 2 incidents in the Gospels that we can look to. The one is in Matthew chapter 15. It's the story of the Syrophoenician woman whose daughter is demon-possessed. She asked Jesus to heal the daughter, and in an unusual statement, Jesus says, it's not right to give the crumbs from the children's table to the dogs. The woman replies, yes, Lord, but even dogs eat from the crumbs of the master's table. And Jesus replies, oh woman, great is your faith. Then he heals her daughter. Second is from Matthew 8 and also Luke chapter 7. It's the story of a Roman centurion whose servant is desperately ill. He comes to Jesus asking Jesus to heal his servant and says, I'm not even worthy for you to come under my roof, but just say the word, and I know that my servant would be healed. Because I know what it is to have authority as a soldier. I say to this person, do this, and another person does that, and it happens. I believe you can do it. Jesus heals the servant and says, I've not found such great faith in all of Israel. Now, what do these two stories have in common? Well, each person drew a practical analogy gleaned from experience from their own lifestyle. The Syrophoenician woman, from behavior she observed with the dogs. The Roman soldier knew what authority was by virtue of his profession and applied that to a belief in the authority that Jesus would have to heal. So I would like to suggest that there are several chronological examples, and I would encourage you, whatever your discipline is, to think of some. You got to do hard work because you can draw analogies that are trite and forced, but let's talk about a couple in mathematics. They're at varying degrees. So here's the graph of the equation y equals 1 over x. If you rotate it about the x-axis, you gradually get a megaphone. Now extend that out to infinity, and you get what's called Gabriel's horn. You can prove mathematically that the volume of this thing is finite. It actually equals pi gallons of paint, say, to fill it. You can also prove that the surface area is infinite. Wait a minute. You can fill it with paint, but you can't paint the surface. Now, this is an example where I think this is easily resolved, and when you study the scriptures, there's going to be things like that. You're going to come, wait, and then you study some more. Oh, yes, I can easily resolve that. Here's something that's a little more problematic. It's known as the Banach-Tarski Paradox. You can take a sphere and disassemble it into 5 sections without distorting them or bending them or stretching them in any way, and then reassemble and get 2 spheres of identical volume to the first. I think that can be resolved, but it's a little weirder. And then there's one that's just mysterious. I call it an irrational conundrum. Between any 2 rational numbers, there's a rational number. Between any 2 rational numbers, there's an irrational number. True. Between any 2 irrational numbers, there's a rational number. Yet there are more rational numbers than irrational numbers, even though there are infinitely many of both. Now, you ask a mathematician to explain that. I've done with several, and the answer is, well, that's just the way things are with infinity. And indeed, if things can get so convoluted in a logically precise, carefully defined world, such as mathematics, it should not surprise you when you run into mysteries or paradoxes relating to your faith. I have a problem shelf of things with my faith, things that just don't make sense. I'm comforted by the fact that it is not the same problem shelf as when I was in college. It keeps changing. You'll find that to be true. Test and see that the Lord is good. You'll find that some of these things can be resolved. Some you just have to live with as a mystery. Can you accept mystery as part of your worldview? That's one of the things that Berkeley was arguing about. So let's close with Berkeley's final. Let's give him the last word. Then I'll circle back to what about that email I got? So these are rhetorical questions. Whether it be not less objectionable to admit points above reason than contrary to reason. Berkeley would say yes. Whether mysteries may not be better right allowed in divine faith than in human science. Well, I'd say you should allow mystery for both, but Berkeley says, no, it's more likely that they would appear in divine faith. In the 6th dialogue of Al-Kifran, Berkeley argues that revelation by definition is going to have things contrary to experience, so it will seem almost foreign to it. Almost by definition, that's the way revelation is. Whether such mathematicians as cry out against mysteries have ever examined their own principles. Whether mathematicians, who are so delicate in religious points, are strictly scrupulous in their own science. Whether they do not to submit to authority, take things upon trust, and believe points inconceivable. Whether they not have their mysteries. These are rhetorical. Berkeley would say, yep, 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 and I agree, yep. Maybe not on this last part. And what is more, their repugnancies and contradictions. I don't know about repugnancies, but the Banach-Tarski Paradox, that's just, ooh, you know, how do you do that? So what about the conversation? That email I got. I emailed him back. Let's go out to breakfast, have a talk. So we did. And I shared more or less this story that I just told you. And he admitted for some points, left, I hope, but he remains a skeptic, left, I hope, with a better appreciation for the allowance of paradox and mystery. And when you think about it, almost by definition, when you think about Gödel's theorem, you can't prove your system is consistent. A mathematician has to have a respectful attitude for mystery and paradox and faith. Because if science deals with what can be proved, and religion deals with what can't be proved, then mathematics is the only science that can prove itself to be a religion. Thanks for coming to my talk.
And some questions?
What made you want to go out of your way to prove to this skeptic about the idea of mathematics as a religion? Like, were you trying to defend the position that mathematics had, or were you trying to defend the religion itself?
So did you really hear what made me go out of my way to respond to this? First thing was he initiated the email. So I felt like I need to reply. I thought that might be a sign of the Holy Spirit working in his life to reach out to me like that. I wanted him to see that the claim that remember his line, I don't have any faith in me. I wanted him to see that's not true. From my point of view, you do have to have faith in order to practice mathematics. And so to have a more respectful attitude. Now, by faith, I don't mean blind trust. I mean, there's good reasons for believing that mathematics is consistent and so on. But if by faith you mean something that I can prove everything, no. I wanted to get him to see that. And he allowed for those points. But he still remains a skeptic about whether there's a God and things. Am I answering your question? I'm looking at you and you're sort of like, you're not happy with my answer, it seems. You want to give the mic and maybe you want to follow up on that, or?
I guess what I was wanting to understand is like what the need to like prove the points as well. Like you mentioned that the Holy Spirit guided him to reply to you, to send you the message, but also it's you trying to prove your point to him to make sure that you're allowing him to understand your perspective.
Yeah, so I'm not sure what your question is. So yeah, that's what I wanted to do. I wanted to convince him that he has underneath a faith commitment that he must make. So if he's rejecting Christianity on the basis of you have to make a faith commitment, and remember, I don't mean irrational commitment, I mean a faith commitment. I wanted him to see that you make a faith commitment as a mathematician. So maybe that doesn't, we could talk after if you want to push back some more on that, but that was my motive. Yeah.
To a black hole?
question was, does Gabriel's horn have similarities to a black hole? If you think of a black hole as this gravitational suction cup, I suppose, and you know, people have hypothesized that black holes are wormholes to an alternate universe, perhaps. I suppose you could have a similarity there, but just in the raw formulation of Gabriel's horn, it's just you rotating this y equals 1 over x and creating this infinite megaphone, so to speak. That's as far as it goes, I would guess. But I'm not sure. If some physicists might say, oh yeah, we use this all the time in black hole theory, I would be surprised. The way, by the way, I get around Gabriel's horn, I said this is easy to resolve. So you can't fill Gabriel's horn. The reason you fill it with paint, you can't fill it, because the molecules in the paint are going to get stuck at a certain level when that horn gets too thin. Now, if someone says, let's suppose God makes the paint with no molecular structure, and we can fill it with pi gallons. Okay, I'd say fine. If God makes a paint with no molecular structure, then you could paint the surface with no molecular structure, because paint involves volume. And you could thin out the paint in proportion to as the paint thins out as it goes down Gabriel's horn, so to speak. So I think that paradox is easily resolved. The other is not quite as easy, but yeah.
Other questions? Let's thank Professor Howell again.
Thank you.